All right, this is Mr. Clancy. We are reviewing for our A.P.E.S exam on Monday, March 4th, and this is the third video. I think we left off here on page 1, and may I encourage you to really put a lot of studying in on this particular sheet, as we have dubbed it 157 reasons to go A.P.E.S. 157 terms, there's a lot of terms, I understand that. But also keep in mind, a lot of these are pretty easy that you've known for quite a while. So focus on the ones that, make sure you read them all, but really focus on the ones, prioritize the ones that you're really not sure about. Let's go over a few of these here, and I've got a couple of diagrams I'd like to show to you as well. I trust you're finding this helpful. I would appreciate some feedback on it as well. And but anyway, so here's what we're going to look at. Ore, I think we left off at nuclear fission and fusion. Ore basically is a mining term. It's rock that you can see has a large enough concentration of a mineral, making it profitable to mine. The mineral could be something like copper, it could be silver, it could be a gold mine as well, it could even be a lead mine or something like that. The idea, if you remember, that one of the very first labs we did was the cookie mining lab. And that's always a big A.P.E.S favorite. And if you remember, the ore itself, I'll just I'm going to make some notes on kind of a separate sheet of paper here. The ore basically was the cookie. I'll put this over here. Right, the ore, if you will, was the cookie. And if you remember, the mineral that basically we were mining was the chips. And we did, if you remember, for one with a lot of chips, one with a smaller amount of chips, and the leftover dough, if you will. In other words, the stuff that, if you remember, we pushed back together in that circle on the graph paper, in effect to reclaim the land, is called the gang. So this is going to be the leftover dirt. All right, after the mineral is extracted. So if you were mining, for example, as an example, in a copper mine, all right, I used to call in these in the state of Arizona, they would typically have their ore, the sulfide ore they would call it, or copper, would be around something like 0.7% copper. All right, so that basically means that out of every, let's make the math easy, out of every 100 pounds of ore, 0.7%, or 0.7 pounds, if you will, is copper. And that would be 99.3 pounds is the gang. And it almost doesn't sound like it's very profitable, but these are enormous size operations, and they turn over a lot of dirt. So by the time they do that, they can actually justify going after this copper, even though it seems like a relatively small amount, or a small percentage for it. Interesting too, they have some veins that might carry as much as 1.0%. Some places. In the ore, and they usually save these for periods of time when there's poor business conditions. In other words, the price of copper goes down. This is used in a tough economic climate. And I always thought that was really amazing that they would actually use this to have the foresight to leave the richer stuff 1.0% alone and just stick with this during normal business operations. But if they had a tough economic climate and they had to lay off workers, then mining this ore, they could, in theory, get, this would help them because they have fewer workers to do the job. It's going to be harder to dig the ore out of the ground, but the ore is more concentrated. So it just helps them with the, basically helps them stay in business during poor business conditions. All right, mineral reserve is identified mineral deposits currently profitable to extract. This is sometimes called, as I just put, this is sometimes called a vein. All right, a vein of mineral deposits. Surface mining is cheaper, I'm going to say cheaper here, than mining. All right, the surface mining is just basically digging a big hole in the ground. Underground mines are, as it sounds like, are all the way underground. They've got elevators going down there and stuff. These are like almost cities underneath there. They're huge operations, but they are not as safe. So mineral underground mining is also very sophisticated from a mining engineering standpoint. Not that surface mining isn't, but surface mining is pretty much digging a hole and kind of layering it. It's just a lot easier to deal with. It's also open to the environment, so you can imagine it's less hazardous to workers. Humus, as you can see, is an organic dark material remaining after decomposition by microorganisms. A lot of these, by the way, are bacteria. I realize my writing is kind of going all over the place, but if you stay with me and follow through with it, I think we'll be okay with this. The leaching is basically removal of dissolved minerals from the soil by water. As water fills down, water is sometimes solvent. And the key thing with water, we need to remember that water actually brings, a key thing with this is that water, so we're going to put this up here, water carries the minerals. All right, lower. Okay, lower in the soil. All right, and basically water is the vehicle for transpiration. Say vehicle for transpiration. All right, that's basically how, for example, fertilizers get into plants. Now, fertilizers are basically dissolved in the water. The water then carries, goes down into the ground and then is carried up, all right, into the plant. Let's see if I can draw a little. I can draw a little tree here. There's my tree. Here are the roots here, root system. All right, pretty primitive drawing. Here's the ground, tree, and basically the water will come down the rain in the form of rain or irrigation, either one. All right, comes down, dissolves it, dissolves the minerals, and then goes up out into the atmosphere, and this process here is called transpiration. The water itself evaporates through the leaves of the tree. The minerals that were in the water are left behind in the tree to help sustain the tree. So it's a pretty good, water is by virtue of its solvent characteristics that can dissolve a lot of stuff. Leaching is an important term to remember. Loam is actually the perfect agricultural soil with equal portions of sand, silt, and clay. If you remember when we had sand had a large particle size. So water goes through it very quickly. Clay has a very small particle size. Remember this from labs. So it compacts a lot. And someplace in the middle here is silt, which has a particle size in between. All right, so if you have a nice combination there with those three, it is pretty cool how you'll have enough water going through. If you have too much clay, like they have for example, in some, we lived in Arizona, there was a lot of clay there, very difficult for the water to penetrate. If you live near a sandy area, the water just rifles right through there. So the silt, clay, and sand, this equal mix is the loam, which basically allows enough water residence time. It allows water to penetrate, but not too quickly, so it has residence time in the soil to be picked up by the plant. Some soil conservation methods: conservation tillage, which basically means we're not tilling the whole thing. We may leave an entire plot of land. We might only till part of it, or we might leave some weeds or some roots of the plant from last year in the soil to help tie the soil together and keep it, make sure there's no erosion. The crop rotation we've talked about with putting different crops in a different area of land. The notable example was the southern farmers. If you remember, we talked about how they planted peanuts and cotton in alternating year. They rotated those crops. That basically was used to increase the yields of both the cotton and the peanuts, and also to keep the boll weevil, which is the insect that attacked the cotton crops, under control. The contour plowing would basically be a contour. I think we showed a picture of this in class recently, but contour plowing is where you're plowing and subsequently planting using the especially on graded areas or hilly areas. All right, and this basically stops erosion. In other words, it slows water flow. And the idea is to make sure you've got enough water that's going to seep down and get into the plants. So that's pretty cool also. The hydrologic organic fertilizers just would not have any, it would basically be manure. I appreciate that, thank you. This would basically be manure that would not, and we'll just say no phosphates nor nitrates. All right, remember, these can cause severe problems in the form of algae buildup, something called eutrophication, if they run off into a pond, like off a hill or something like that, if they're over fertilized. The hydrologic cycle, the water cycle, you should be pretty familiar with these, I think. Evaporation, of course, going from a liquid to a gas in the atmosphere. Remember, that occurs, that will go heavier or at a faster rate depending on temperature, right? And also depending on wind and so forth. Transpiration is the water going through